On the next screen, what we started to do is try to determine if we have any extrema for this particular function, whether we have any minima or maxima. So we determine that by taking the derivative, y prime, and in this case we're forced to use the quotient rule to do so. We want to take that particular derivative and we want to set it equal to 0. So we end up with 0 is equal to negative x squared minus 9 divided by x squared minus 9, where that denominator is all squared. In order to set that particular expression equal to 0, really all we have to do is set the numerator equal to 0. So 0 is equal to negative x squared minus 9. And if you used your quadratic formula, you would find that there are no real roots to this. Therefore, there are no extrema for this function. That doesn't mean that the function is either solely increasing or decreasing. Remember that around vertical asymptotes, on either side of it I should say, a function can change from increasing to decreasing or vice versa, or it may not change at all. So when we're trying to determine increasing and decreasing intervals, we not only look at extrema that we may have calculated, but we also have to consider vertical asymptotes because, as I just mentioned, the function can indeed change from increasing to decreasing or vice versa across those vertical asymptotes. So I've put down a number line, and I have no extrema to write on this number line, but I do have the two vertical asymptotes. So I put down the negative 3 and the positive 3, and that shows me that I have three intervals that I have to test. So I'm going to test y prime, and y prime was the negative x squared minus 9 divided by x squared minus 9, all squared in the denominator. So I'm going to test y prime at x equals negative 4, x equals 0, and x equals 4. Those are the values that I chose in my three intervals. Again, you could have chosen any values you wished. When I took the x value of negative 4 and substituted into my first derivative, I got the value negative 0.51. So I place a negative on my number line. That indicates that my function is decreasing from negative infinity to negative 3. Then I took the x value 0, substituted it into y prime, my first derivative, and got negative 0.11. So my function is decreasing from negative 3 to positive 3. And then I substituted the x value of 4 into my first derivative, y prime, and obtained negative 0.51. Another negative value, so I know my function is decreasing from 3 to infinity. So I do not have any increasing intervals at all for this particular function, so I say that for increasing, my x values are a member of an empty set.